We're right on the edge of a massive shift in artificial intelligence. We're moving beyond AI that just, well, talks, to an AI that actually does stuff. And this isn't just some tiny little tweak, it's the next huge leap in what AI can do for us. And today, we're going to break down exactly how it all works.
So let me ask you this. Have you ever been in the middle of a chat with an AI like ChatGPT and just wished it would stop giving you instructions and just, do the thing? Like, hey, can you book me a flight? Or just order the pizza already? And what happens? It probably spits out a perfect step-by-step guide on how you can go and do it yourself. And that's exactly the limitation we're here to solve today. We are going to build an AI, step by step, that doesn't just tell you how, it actually gets it done.
Okay, so to get started, we really need to get our heads around the main limitation of today's large language models, or LLMs. Models like GPT, they're basically amazing prediction machines. They're designed to guess the next word or the next pixel in an image. They are brilliant at that, but they have zero built-in ability to take any kind of action in the real world. And this really highlights the fundamental difference. Think of it this way. A chatbot gives you a recipe. An AI agent is actually in the kitchen cooking the meal for you. It's designed from the ground up to take information and then perform an action. That's the endgame here. All right, so this brings us to our very first upgrade, giving our AI the power to act. We're about to transform it from a simple chatbot into a much more powerful AI agent. So what is an AI agent exactly? Well, you can think of it as a program that has three key parts. First, it can interact with outside tools, like websites or different software. Second, it has its own memory, so it can keep track of what you've talked about and what your preferences are. And third, it uses a powerful LLM as its brain to think, plan, and carry out actions to get a job done. So these are its superpowers in practice. It can connect to an airline's website, remember you told you prefer an aisle seat, and then use its LLM brain to compare all the prices. But here's the really crucial part. It persists. It doesn't give up. It keeps working, trying different things until that flight is booked. And that same persistence lets a developer agent, say, troubleshoot code, just analyzing files over and over until it finds and fixes the bug. Awesome. Our agent can act, but boom, it immediately hits a new wall, what I like to call the API language barrier. See, to do anything useful, it has to talk to other services online. But it turns out they all speak different digital languages. Now, to really get this barrier, you have to know the difference between a UI and an API. The user interface, the UI, that's the pretty website that you and I see. It's made for humans to click on. The application programming interface, or API, is like the secret back door. It lets computer programs talk directly to each other. It's made for machines. And this is where the problem starts. To get a simple list of flights, our agent has to know that one airline calls its API/API flights, but another one calls it /flights list, and a third one calls it /list flights. They all do the exact same thing, but the commands are completely different. It's a digital Tower of Babel out there. And this just raises a huge question. I mean, it's one thing to teach our agent 3 different airline APIs, but what about hundreds of airlines, or thousands of hotels, or millions of different services all across the web? How could one agent ever learn to interact with all of them? And that is what brings us to our next big upgrade, a universal translator for our AI. The solution is called MCP, which stands for Model Context Protocol. So MCP is basically an open source standard. Think of it like a shared rulebook. It doesn't actually replace all those messy APIs. Instead, it sits right on top of them, and it gives our agent the context it needs to figure out what an app can do and how to use it, without needing to learn the nitty-gritty details of every single unique API out there.
So first, let's just look at the before picture. You've got our poor agent, and it's trying to connect directly to 3 different airlines, each one with its own weird, confusing, unique API. This is slow, it's inefficient, and it's basically impossible to scale up.
But now check out the after picture. With MCP, our agent isn't talking to those messy APIs directly anymore. Instead, it connects to these clean, standardized MCP servers. These servers act like middlemen, translating the agent's simple requests into the specific API language each airline understands. Suddenly, our agent only needs to speak one language, MCP.
Okay, so we've built an incredibly capable agent.
It's smart, it can act, it can talk to anything, but to solve the really, truly complex problems, we need to make one final upgrade. We're moving from a single agent to a collaborating super team. So what's the new problem? Well, our agent is a rock star at booking flights. But what if we also need it to book hotels and find rental cars? If we just keep cramming more and more skills into our one agent, it gets bloated, it gets slow, and it actually gets worse at its main job. The solution here is specialization and collaboration, and this is all made possible by an agent-to-agent model. You can think of it as a set of rules that lets individual, specialized agents find each other, communicate, and work together on a much bigger goal.
And the way they collaborate is surprisingly simple. It just follows 4 basic steps. A main travel agent can ask a hotel agent, "Hey, what can you do?" The hotel agent tells it. Then, the travel agent assigns a task. "Okay, find a 5-star hotel near this airport." They communicate back and forth, and the hotel agent reports back when it's done. It's like having a team of experts, all working in perfect sync.
So let's just quickly recap the whole journey. We started with a basic LLM that could only talk. Then we upgraded it to an AI agent that could actually take action. Then we gave it MCP, that universal translator, so it could speak any API language. And finally, we created a whole team of specialized agents that can collaborate to solve really complex problems. All right, so if you take away nothing else, here are the 3 key things to remember. First, AI agents are the upgrade that lets AI go from just talking to actually doing. Second, MCA is that universal translator that solves the whole API language barrier. And third, agent-to-agent models let us create these collaborative super teams of specialized AIs. And this brings us to one final thought. Now that you understand the whole architecture, from a single LLM all the way to a coordinated team of expert agents, I'm going to leave you with this question. What truly complex, maybe even world-changing super task would you give to your own team of AIs?